two functions on the same set of axes. And the first question is to do with g, so I'm just going to consider this graph here. Now we're told that the graph is y equals g of x, which basically means that the y-axis represents g of x, and the x-axis is obviously just x. So to find g of 0, what that actually means is that x is 0, so the x value is 0. What is the y value? Well, if we look at the graph of y equals g of x, if the x value is 0, the y value that goes with that is here, which is actually 2. So g of 0 is actually just 2. Okay, if we go on, the question says find gf of minus 1. Now, one thing that you should remember about functions is when we find gf of minus 1, what that means is that g has to be done to f of minus 1. So our first job is to find this, which is f of minus 1. So let's look at the f graph this time, and we are trying to find f of minus 1. So the x value is minus 1, which is here. The y value, which is going to give us this f of minus 1, is found by going up to this point here. So we can see that f of minus 1 is actually 8. So instead of f of minus 1, I can write 8. So our job now is to find g of 8. So we're now going to use the g graph. Now to find g of 8, the x value is 8, but the g value, so the y value that goes with that, is actually here, which represents minus 2. So the y value is minus 2, so g of 8 is actually just minus 2. Okay, which we can write here. The question then asks us to calculate an estimate for the gradient of the curve y equals f of x at the point where x is 3. So first of all, let's get the right curve. Now y equals f of x is this one. At the point where x is 3, well, that's halfway between 2 and 4, so that's at this point here. So on the graph, we are talking about this point here. So our job is to find the gradient, or estimate the gradient of the curve at that point. And what we need to do there is draw a tangent to the curve. So I'm going to just do a little one to start with. So if we draw a tangent to the curve, which goes in about that direction, and let's just make that a little bit longer. So tangent to the curve goes to there, and then if we make it longer in this direction, it goes up to about there. Oops, it's wiggling around. Okay, and we've now got to find the gradient of that line there. Okay, if we just extend it a little bit, so we're going to find the gradient of the line, which is there. Now, the bigger a triangle you can draw underneath in order to find the gradient, the better. I would say let's go from this point here. So you need to have a whole number of squares, although that's not going to be particularly easy in this case. Let's go over to there and maybe go up to there. Now, to find the gradient is obviously negative to start off with. If we count the number of units up this side, look at the scale carefully. So each centimetre is 2 units. So up to here is 8, and then so it's going to be about each 1 square is actually just 0.4, so it's going to be about 9.2 up there. Okay, because it's just a little bit above 1. If we go across, that's minus 2, and that goes up to, well, here we have 6, and so it goes up to 6.4 or thereabouts. So from minus 2 to 6.4, that is about 8.4. So the gradient of the curve is negative, and it's the vertical, which is about 9.2, divided by the horizontal, which is about 8.4. Now that comes out as about minus 1.1. You can't afford to be you can't be too accurate here. It also depends how accurately you draw your gradient, your tangent rather, but you are allowed to have anything between minus 0.7 going up to minus 1.4. Okay, but you must show your method, so you must draw that tangent and you must show what you divide, the division that you do here.